Now, when we study college algebra, one of the things that is one of the key concepts in college algebra is that of the function. And what we do for the most part in college algebra is study functions. Now, functions are something you work with all the time. And you're not even realizing, you don't think, I'm working with a function. But a simple thing like when you agree to work for $10 an hour, and let's say you work between 0 and 40 hours a week. That right there defines a particular function. It defines a function, a pay function, where it's like a machine. If you work 1 hour, you're going to get $10. If you work 2 hours, you put in a 2, you get out a 20. So you put in 2 hours of work, you get out $20. You put in 3 hours of work, you get out $30. So this right here is a function. And that's what a function is. A function is a rule where it assigns one value to another value. So a different way to look at it would be this, where you've got 1 mapping over to 10, 2 mapping over to 20, and so forth. And we could go on and list list a bunch of different values, but 3 is enough to show you what's going on with a function. So we've got here this mapping. Here we've got a little table. Both of these are representations of the function. And here we've just got it written out. All 3 of these are ways to represent the function. But the thing is, they are not very concise. In other words, we don't want to have to talk about this function with a table or this thing here, this mapping, or an English sentence here. What we would like to do is have a mathematical formula, since we're studying mathematics. And what we usually do is we have something like this. This is read P of x is equal to 10x, because where x is the number of hours we work. And I use P here. This could be anything. It could be A, B, F, whatever. But this is a function, and this is read P of x is equal to 10x. In this particular context, it means our pay is a function of the number of hours we work. See how that works? P of x. And we could evaluate this function. Notice we could say P of 1 is equal to 10 times 1. Notice we just replace the x with a 1. P of 2 is equal to 10 times 2. And this is times here. Now this over here, this is not multiplication. This is, however. And I didn't multiply it out, but you can see, you know how to multiply it out. P of 3 is equal to 10 times 3. That would be 30. So this is the function notation, the mathematical way that we can express that function. And we would have the terms defined. This right here, the x, that's called the independent variable. The P of x, all of this, is the dependent variable. This pay depends on the number of hours you work. So we talk about this part over here. We've got these functions. This function represented different ways. The input we describe as the domain of the function. Now, this particular function has a domain of hours between 0 and 40. So, for example, you can't work -1 hour. You work 0 up to 40 hours, and those values those represent the domain. The output here we call the range. So here's the input, here's the output. Now, a formal definition of a function is a function f from A to B is a rule of correspondence. In our case, the rule of correspondence would be you tell me how many hours you work, and I'll tell you how much you get paid. You work 3 hours, you get $30. Okay? So there's a rule of correspondence. Every hour you work corresponds to an exact amount of pay. And only one amount of pay. So it's a rule of correspondence from A to B is a rule. It's a rule of correspondence that assigns each element in A, the domain, the number of hours you work, to exactly one element in B, the pay. A is the domain and B is the range. That's a little bit more formal definition of a function. Now, not all rules of correspondence are functions. Let's look at this. Notice this one here. This is a function because notice every x in this little oval corresponds to exactly one y over here. See, there's one arrow coming from x1, one arrow from x2, one arrow from x3. Each one of these corresponds to exactly one value, no more, no less. Now let's look at this second one. Look at this. Here's an x1. It has two arrows coming from it. So this element corresponds not to exactly one element over here. It corresponds to two elements. So this is not a function. Now let's look at this third one. x1 corresponds to exactly one element, y1. x2 corresponds to exactly one element, y1. And x3 does the same. Now it doesn't matter that they all correspond to the same element. The fact is, every element over here corresponds to exactly one element over here. So that's a function. Now let's look at this one. x1 corresponds to three things. Well, that's certainly not a function. So here we have, over here we have two functions. Over here we have, neither of these are functions. So this gives you an idea. When we talk about a function, we're being specific. Every input gives you exactly one output.